Okay, so slopes of parallel lines and perpendicular lines. So we know how to calculate slope now. If you're given the graph, form a right triangle, find the rise, find the run, and it's the ratio. If you're given points, use that formula. Okay. So now we're going to look at particular lines. So these lines are parallel. So what do you think about their slopes? If you were trying to walk up those lines, would it be the same effort in each line? Yeah, they're the same slope. So parallel lines have the same slope. So their slopes are equal. Okay. So the rise and the run are the same. Okay. The ratio of the rise and the run. So now we're going to verify with some actual lines here. So take a look and calculate the slope. Notice how we pointed out some nice points so that you don't have to guess. If ever on a test you're asked to calculate the slope and you're given a line, not the coordinates, but a line on a grid, look for where the line crosses an exact grid crossing. Or look for sometimes we actually put a dot on it so that you don't have to estimate anything. So in L1, okay, so here I'm going to go up and to the right. So I'm going up 2 to the right 6. So 2 over 6, which reduces to 1 over 3. Okay. L2, up 1 to the right 3. Okay, so I'm just using the points that are given because why bother creating more work for yourself? Okay, so 1 over 3. So far those are equal. Third line, going up and to the right to get from point to point, that's 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 over 9. And that reduces to 1/3. Okay, so all of these slopes reduce to the same value. Okay. All right, so they reduce to the same value. That's pretty easy. So if I tell you the slope of a line and ask you to find the slope of a different line that is parallel, you don't have to do any calculations. You just tell me that original slope. Perpendicular is different. So it says the following lines are perpendicular. What do you think is true of their slope? So just in general, when looking at it.
Well, the slopes are reciprocals of the slopes are reciprocals of each other, and one is positive while the other is
Negative, right. So the reciprocals part is a little bit harder to see here without a grid, but you can tell the positive and negative part. This line is going up and to the right, so that's positive. This line is going down and to the right, so it's negative. So that's easy to see. It's the other part about the reciprocals that in that question, or that diagram, a bit harder to see. We're going to look at some actual lines on grids. So they are opposite in sign. And I'm going to put in brackets and reciprocals. I'm putting it in brackets because it's hard to tell from that diagram. Okay, so here we're going to do some calculations. So these are perpendicular lines. So if you notice how the grids are perfect, they are squares, okay, not rectangles. So the scale is equal scale and they're squares. So basically it does look like they meet at 90 degrees, okay? If you got a protractor out, then you can measure it as 90. It says calculate the slope. So here, in L1, here that's under, there's space for it. So L1, look for 2 of the points. We've plotted them for you. So up 3 to the right 2. For L2, use the points given from the left point to the right point. 1, 2, 3, 4, down 4. 1, 2, 3, 4, 5, 6, to the right 6. And reduce it. Okay. Do the same for the next diagram. Slope of L1, slope of L2. Okay, so based on what we were talking about before, notice how 1 is positive, 1 is negative. 1 is positive, 1 is negative. If you take a look at the actual fraction, 3 over 2, and you take the reciprocal of that, that's 2 over 3. Here, this is 4. Remember, 4 is the same as 4 over 1. The reciprocal of 4 over 1 is 1 over 4. So that kind of goes back to what we predicted, that slopes of perpendicular lines, the fastest way to say it is they are negative reciprocals of each other. Okay. Yeah. Well, if you're looking at 2 perpendicular, one's going to have a positive, one's going to have a negative. Yeah. Doesn't matter which one. Depends which you calculate first. Okay. Now I want to show you something else with these. What happens if I take the slope of L1 and multiply it by the slope of L2? What number do I get? What's that? Negative 1. Okay. Let's check that here. 4 times negative 1/4. What do I get? I get negative 1. So if you're given slopes of 2 lines and asked if they're perpendicular slopes, you can either take one, find the negative reciprocal, see what it's at, or multiply them together and see if you get negative 1. Okay, negative reciprocals will give you a value of negative 1. So that's something else to think about. Sometimes that's an easier process to use. Okay. So, I'm going to give you a few minutes to fill in the table there. So slope of all parallel lines parallel, they're all going to be exactly the same. Those are the easiest marks in any test you'll have, right? Parallel slopes are the same. Copy them out. Perpendicular, you're going to have to take the negative reciprocal. And think about what happens in these ones. So I'll give you a minute to work on that. Okay, so all those parallel slopes, they're the exact same value. Perpendicular, take the negative, so if that was positive, this is going to be negative, and the reciprocal of it. If that's negative, this is going to be positive, take the reciprocal. So one's negative, one's positive. Positive 2 will be negative. Remember how 2 is the same as 2 over 1. Okay, this is in simplest form, but that's 2 over 1, so that's going to end up being negative 1 over 2. Negative 5, that's like negative 5 over 1, so this will be positive, and it'll be 1 over 5. Anytime it's an integer, the reciprocal is going to be 1 over. Okay. Now, think about zero slope. That's a horizontal line. Perpendicular, that's the floor. Perpendicular to it is me, standing straight up. That's a vertical line. Vertical line has undefined slope. Undefined slope is a vertical line. Perpendicular is the floor. Floor has zero slope. So these are reciprocals, in a way, right? 0 would be something like, so you could show that, say 0, say it was 0 over 5. Then this would be negative 5 over 0. Well, when you divide by 0, it's undefined. Undefined would be something like 5 over 0. Negative reciprocal would be negative 0 over 5. Well, 0 divided by 5 is 0, right? The negative, you can't have a negative 0, right? It is 0. So that's how, if you actually look at the numbers, that's how that works. Okay. Next one, draw the line passing through that point that is parallel to the line passing through BC. Okay. So A is negative 4, 2. B is negative 2, 1. C is 5, 4. Okay. So A has to be parallel to BC. So join BC up. So here, let's see if I can. Okay. Oh, it's a funny glue, but whatever, works. Okay, so now we could calculate the slope here. So it's going up and to the right. So it's going up 3, 3, 6, 7, to the right 7. So from this point A, we want to do the same thing. We want to go up 3 to the right 7. 3, 6, 7. Okay, and it says line passing through. So that means we're going to draw a line. And here on my smartboard, I can just own it. Okay, so I'm going to take that, and it's going to go through A and this new point. Maybe I'll do a different color now. Okay. So you could, if you didn't have the grid, you could calculate the slope using the formula. Okay, and then use that to get more points. But you have the grid. So graph it, draw your triangle, and do the same. Right? So this triangle here, 3, 7. Should be the same size. Okay, next one. Draw the line passing through A that is perpendicular to BC. All right, so A is 3, negative 2. Perpendicular to the line passing through B, which is negative 2, negative 3. C, 0, 3. Okay, so I'm going to draw a line going through that again. Invest in a ruler if you haven't already. There we go. It's a little unaligned. Okay. So it has to be perpendicular. Looking at this, kind of looks like it's going to be, oh, darn. Okay, just a second. Kind of looks like it's going to be kind of meeting like that, right? And extending on. But we want to make sure it's exact. So this line BC, if I'm going up and to the right, 1, 2, 3, 4, 5, 6, to the right 2. So that slope is 6 over 2, which is 3. Okay, so that must mean I have to do the opposite, right? Now this rise becomes my run. Okay, so this rise of 3 becomes my run, or we can go back to the original. So now I'm going to go 6 to the left. I'll do it in green. So 3, 6 to the left and 2 up. Okay, so I'm on the right track. That line there, see how I was pretty darn close. It's going to go like that. Okay, and then I can extend this a little bit further. And that I will do in green. Okay. So that angle in there will meet at 90 degrees. Okay, again, you can use the formula to calculate the slope between B and C, but you're given grid paper, so don't really need to. Okay, question 10. The slope of L1 is 5 over K, and the slope of L2 is 4 over 3. Determine the value of K if they are parallel. So take a look at the notation here. Can you guys put your phones away, please? Okay, so parallel are two vertical lines, equal distance apart. That's the notation. Perpendicular is an upside down T, because that meets at 90 degrees. Sometimes you'll also see it as an upside down T with that 90 degree symbol, that little box. So either one. Okay. All right, so if these are parallel, L1 and L2, that means, so therefore, 5 over K has to equal 4 over 3. Slopes of parallel lines are equal. So solve for K there. It's not going to be a nice value. You're going to need to use fractions. Don't use decimals. Okay, and then divide by 4. You get 15 over 4. Okay, so it's going to be a fraction in some cases. Okay, perpendicular, a little bit different for that. So remember, they're negative reciprocals of each other. So if you're given 4 over 3, perpendicular, so perpendicular to L2, you can use that perpendicular sign, would be negative 3 over 4. Actually, I'll put it down here. L2 perpendicular equals negative 3 over 4. Okay, so any line, what's that? It's raining. It's okay. We're all right. Okay, any line that's perpendicular to L2 will have the slope -3/4. Okay, and we're told L1 now is perpendicular to L2. So that means that L1 is 5/k. That's going to have to equal -3/4. So now solve that. Okay. Yeah. Yep. Exactly. So you multiply through by 4k. Okay. So that's one way. The other way is to think about my other sort of definition of slopes of perpendicular lines. They multiply to -1. So that we could also say slope of L1 times slope of L2 equals -1. So that would be 5/k times 4/3 equals -1. Sorry. That there. So that's going to be 20/3k equals -1. If we solve that equation, we end up getting 20 equals -3k, so k equals -20/3. Okay, same answer. So you decide whichever method you like better for that. Okay. And then the last one, determine the value of y if we're given the coordinates of A, B, and partially of C, and we're told that line segment AB is perpendicular to BC. Okay, so you might want to do a little sketch just to visualize. So 5, 2 would be about here. 2, -4 would be about here. And C, 8, Y. So that would be, we want AB to be perpendicular to BC. So if 8 would be kind of here, it's likely going to be down something like this. Right? So it has coordinates 8, something. Okay. All right, so find the slope of AB. Then find the slope of BC. BC will have a y in it. You won't be able to calculate the actual value. So remember your formula for slope. Put it down here. Slope is y2 minus y1 over x2 minus x1. Okay, so AB is going to be -4 minus 2 over 2 minus 5. That's slope of 2. Makes sense that it's positive if you look at your little sketch. AB has positive slope. BC is going to be y minus -4 over 8 minus 2. Simplify as much as you can. Okay. Now, it says they have to be perpendicular. So remember, look for the slope that you do know. So this slope of AB, if I want a slope perpendicular to it, then it's got to be the negative reciprocal. So slope perpendicular will be negative 1/2. Okay? So I use that little symbol to remind myself that's perpendicular. Therefore, negative 1/2 is equal to y plus 4 over 6. Because this slope is negative 1/2, and it's also this expression. We just don't know what that y value is, but that's how we can find it out. So now multiply through by 6. And solve for y, you get negative 7. And that makes sense in my diagram. That y value is going to be a negative. Less than the y value of b, which was negative 4, so that makes sense.